Welcome to e-learning classes managed by Modern English School, Nevada. Dear student, myself Sujay Kumar, your mathematics teacher of Modern English School, New Area, Nevada. Today I discuss the new part of polynomial, and that is cubic polynomials. Dear students, a polynomial whose degree is 3, that is cubic polynomial. If a polynomial whose degree is 3, that means the number of the zeros are 3. Otherwise, you can say that the number of the roots are 3. The naming of the roots of the cubic polynomial are alpha, beta, and next gamma. If quadratic polynomial, then roots are only alpha and beta. Now, if cubic polynomial, then its roots are alpha, beta, and gamma. Like as a quadratic polynomials, a relationship between their zeros and coefficients, and you all find it by the alpha plus beta minus b by a, alpha into beta c by a. Similarly, a relationship between the coefficient of cubic polynomial and the roots of the cubic polynomial. So today I discuss starting from here, what is the relationship between the zeros of cubic polynomial and coefficient of the cubic polynomial. The cubic polynomial, the standard form of cubic polynomial is ax cube plus bx square plus cx plus d. It is the standard form of the cubic polynomial. Your question is, find the relation between the zeros and coefficients of a cubic polynomial. Dear student, I suppose here let alpha, beta, and gamma. Here is cubic, so number of zeros are 3. So alpha, beta, and gamma are the roots of a cubic polynomial, Px. And polynomial is ax cube plus bx square plus cx plus d, where a is not equal to b. Because when a is 0, then x is 0, so then it is quadratic. So here you write compulsory that a is not 0. Then if alpha, beta, and gamma are the roots, then x minus alpha, x minus beta, and x minus gamma are the factors of the polynomial Px. So ax cube plus bx square plus cx plus d is equal to k x minus alpha, x minus beta, x minus gamma, where k is constant, and it is equal to cubic polynomial. Now ax cube bx square cx plus d is equal to k. First multiply between here. So x into x, x square, alpha into x minus alpha x, beta into x minus beta x, and alpha into beta, alpha beta, and into x minus gamma, and here is curly. Now this is multiplied by x. So x into x square, x cube, minus alpha x square minus beta x square and plus alpha beta x. Now multiply by gamma. Then it is gamma x square minus alpha gamma x, multiply alpha gamma x, and minus alpha beta gamma beta x, and minus alpha beta gamma. When you multiply by gamma, then you get gamma into x square, because there is minus, so minus here, and minus gamma into minus alpha x, then it is minus minus plus alpha gamma x, and minus gamma and minus beta x, then gamma beta x, and minus alpha beta gamma. And now next step. Now ax cube plus bx square plus cx plus d is equal to k x cube minus alpha square minus beta square plus alpha beta x minus gamma x square plus alpha gamma x plus gamma beta x plus minus alpha beta gamma. Now arrange here according to their degree. Here is ax cube bx square cx plus d. Here is k, I write k. X cube is only 1, so I write x cube. X square are 3, alpha x square, beta x square, and gamma x square, and all have negative sign. So I write here minus alpha x square minus beta x square minus gamma x square. Now I write with x, write alpha beta x. Here is right alpha beta x plus, I write plus alpha beta x plus beta gamma x. Here is beta gamma x. I write beta gamma x, and here is alpha gamma x. I write alpha gamma x minus alpha beta gamma. I write minus alpha beta gamma, and curly colors. Now arrange here. K. Here is x cube minus take common, and then alpha plus beta plus gamma and x square are the common. Plus alpha beta, beta gamma and alpha gamma and x, and minus alpha beta gamma curly colors. Now multiply by a. Then it is kx cube minus alpha beta gamma kx square plus alpha beta beta gamma kx and minus alpha beta k. Now compare between their degrees. Here is x cube and there is kx cube. So compare between them. So x cube cancel. Then k is equal to a. Next, here is minus alpha beta gamma kx square. I write minus alpha plus beta plus gamma kx square is equal to bx square. I write bx square. Then alpha plus beta plus gamma is equal to minus b by k, because here is minus, so minus b by k. So k is the a, therefore minus b by a. So alpha plus beta plus gamma is minus b by a. It is the relation between the sum of the zeros is minus b by a. Third step, alpha beta beta gamma and alpha gamma kx. Alpha beta beta gamma kx is equal to cx. Their coefficient is x. Cx. So x cancel. So alpha beta plus beta gamma plus alpha gamma is equal to c by k. That is c by a. Place of k is a. And last step, minus alpha beta gamma k is equal to here d. So I write alpha beta gamma k is equal to d. So alpha beta gamma is equal to minus d by k. And it is minus d, and the place of k is a. So there are three relations. Alpha sum of the zeros is minus b by a, that means coefficient of x square by coefficient of x cube. Alpha beta plus beta gamma plus alpha gamma is equal to c by a, and last relationship is alpha into beta into gamma is equal to minus d by a. It is the relationship between the zeros and the coefficient of the cubic polynomial. Now this relation we use in the exercise to solve the problem. Now see example first of exercise 2b, that is verify that 3 minus 1 and minus 1 by 3 are the zeros of the cubic polynomial px is equal to 3x cube minus 5x square minus 11x minus 3, and verify the relationship between its zeros and coefficient. There are two questions in this question. First, find that it is 0 or not. So one by one we check it. So rule of this question is you put the value of x in the equation, and if we get 0, then it is clear it is the zeros of the polynomial. What is the zeros of the polynomial? Px is a polynomial and alpha is any roots. Then p alpha is equal to 0. Then alpha is the zeros of the polynomial. That means if 3 put in the equation at the place of x and we get 0, then it is clear it is the zeros. It is clear it is the roots. So first you write equation that is px is equal to 3x cube minus 5x square minus 11x minus 3, and zeros are 3. So we write here 3. Then 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3. It is 3 into 27. It is 5 into 9. It is 33. It is 3. It is 81. It is 45. It is 36. Then 81 minus 81. That is 0. So it is clear 3 is the roots of the equation. Similarly, you write now next 0 is minus 1. So at the place of x, you write minus 1. So now p here is minus 1. You write here 3 into minus 1 cube minus 5 into minus 1 square minus 11 into minus 1 minus 3. Then it is 3 into minus 1 and minus 5 into 1 and plus 11 and minus 3. Then it is minus 3, it is minus 5, it is plus 11 and it is minus 3. Then minus 3 minus 5 minus 3 is minus 11 and it is plus 11. Then it is equal to 0. then it is minus 1 is the zeros of the polynomial. Third your question is minus 1 by 3. So dear student, now we will put here minus 1 by 3. Then 3 into minus 1 by 3 to the power cube minus 5 into minus 1 by 3 square 11 into minus 1 by 3 minus 3. Then it is 3 into minus 1 by 27 minus 5 into 1 by 9 and plus 11 by 3 and minus 3. Here is minus 1 and minus 2 is plus. 3 9 are. So now take LCM. LCM is 9. Then it is minus 1. It is minus 5. It is 3 3 are 9 and then 9 3 11 are 33 and 9 3 are 27. Then we write minus 6 and minus 27, that is minus 33 plus 33 by 9. Then it is clear, it is also 0. So it is satisfied that 3 minus 1 and minus 1 by 3 are the zeros of the polynomial. In cubic polynomial, you have to verify that it is 0 or not. Then we substitute the value of the zeros in the equations. If you get solution will be 0, then it is clear it is the zeros of the polynomial. Now find the relationship of the zeros and the coefficients. So first you write what is alpha. Alpha is 3. What is beta? Beta is minus 1. What is gamma? Gamma is minus 1 by 3. Now write A, B, C, D. What is A? A is the coefficient of x, that is 3. What is B? B is the coefficient of x square, that is minus 5. What is C? C is the coefficient of x, that is minus 11. And what is D? D is the constant term. First relation is alpha plus beta plus gamma is equal to minus B by A. Verify the relation. Alpha is 3, beta is minus 1 and gamma is minus 1 by 3 is equal to minus B by A minus 5 by 3. Take here LCM, that is 3. Here is 9 minus 3 minus 1. Here is plus 5 by 3. You solve it, then you also get 5 by 3 is equal to 5 by 3. So it is verify the relation that alpha plus beta plus gamma minus B by A. Then alpha plus beta plus gamma is 5 by 3 and minus B by A is also 5 by 3. Then both are equal, so it verify the relation. Second relation is alpha into beta. Second relation is alpha into beta plus beta into gamma plus gamma into alpha is equal to C by A. What is alpha into beta? That is 3 into minus 1 plus beta into gamma, that is minus 1 into minus 1 by 3 plus gamma into alpha. It is the relation. Next C by A. What is C? Minus 11 by 3. Now solve, you get here minus 3, here minus minus plus 1 by 3 and here is 3 cancel, that is minus 1. It is minus 7 by 3. Take LCM. LCM is 3. Here is minus 9. Here is plus 1. Here is minus 3. It is minus 7 by 3. What you get here? Minus 9 minus 3 minus 12 plus 1, that is minus 11 by 3. So you write here minus 11 by 3 is equal to minus 11 by 3. Because 9 minus 3 minus 12 plus 1, that is minus 11 by 3 and C by A is also minus 7 by 3. That means second relation is alpha into beta plus beta into gamma plus alpha into gamma is equal to C by A. So first we find alpha, beta, gamma and then A, B, C, D and substitute their value only the equals. And last relation is alpha, beta, gamma. Last relation is alpha into beta into gamma is equal to minus D by A. Alpha is 3, minus 1 and minus 1 by 3. Minus D. D is minus 3 and A is 3. What you get? 3 cancel. That is minus 1 1 and it is also 3 by 3. That is 1. Then 1 is not 1. then it is clear alpha into beta into gamma is equal to minus d by a. So there are two questions. First, verify the zeros, then substitute the value of alpha, beta, gamma in the equation, and next find the relationship between their zeros and coefficient. So there are three relationships in the cubic polynomial. First, alpha plus beta plus gamma is equal to minus b by a. Second, alpha into beta plus beta into gamma plus gamma into alpha c by a. And third, alpha into beta into gamma minus d by a. And both are, all three are satisfied. So it is the question. Now see example 3. If the zeros of the polynomial x cube minus 3x square plus x plus 1 are a minus b, a and a plus b, find a and b. Your question. First write polynomial is x cube minus 3x square plus x plus 1 is equal to 0. Then a is equal to 1, b is equal to minus 3, c is equal to 1 and d is equal to 1. What is alpha? Alpha is equal to a minus b. What is beta? Beta is equal to a. And what is gamma? Gamma is equal to a plus b. There are three relations. Use it. Alpha plus beta plus gamma is equal to minus b by a. Alpha is a minus b, beta is b, and gamma is a plus b. Is equal to minus b is here 3 and a is 1. Here you see, here is plus b and minus b. A minus b, a minus b, a and a plus b. Then b we can see. Then you get 3a is equal to 3, so a is equal to 1. So you can find a with the help of alpha plus beta plus gamma. Now next equation you can use this, that is alpha beta gamma is equal to minus d by a. What is alpha? A minus b, a plus b, and minus d. What is d? It is 1 by a. That means it is minus 1. And multiply it, then you get a square minus b square into a is equal to minus 1. The value of a is given, so you can write it is 1 square minus b square into 1 is equal to minus 1. So what you get here? You get 1 minus b square is equal to minus 1. Then minus b square is equal to minus 1 minus 1. Then minus b square is equal to minus 2. Can you see? Then b is equal to under root 2. So a is equal to 1 and b is equal to root 2. It is your solutions. With the help of the relationship of the coefficient and the zero, then you can find a, b, c, anything. Cubic polynomial whose zeros are given. That means alpha given 3, beta given 1 by 2 and gamma given minus 1. What is the polynomial? You can easily write that polynomial is x minus 3, x minus 2 and x minus minus 1. That is the polynomial. So we write x minus 3, take LCM, that is 2, 2x minus 1 and it is x plus 1. So first you multiply this, then you get x minus 3 and x plus 1 and it is 2x minus 1 is equal to 0. This 2 goes that side, then you get 0. And multiply, you get x square minus 3x plus x minus 3. And it is 2x minus 1 is equal to 0. Now multiply, you get 2x right here. Multiply by 2x, then you get 2x cube. 2x cube minus 6x square, 6x square plus 2x square, 2x square minus 6 minus 6x, 6x. By multiplying 2x, get 2x cube minus 6x square plus 2x square and minus 6x. Now multiply by minus 1, minus x square plus 3x minus x plus 3x minus x and plus 3. So your polynomial is x cube is only 1, that is 2x cube. A square is here, there are 3. So minus 6 and minus x square minus 7 and plus 2, that is 5x square. And x is minus 6 and minus 7 plus 3, that is minus 4x, minus 6 minus 1 minus 7 plus 3, that is minus 4x and plus 3. It is the cubic polynomial. So dear student, if you have given 0, then if multiplied with their factor, then you get the polynomial. That if 0 alpha is 3, next beta is 1 by 2 and gamma is minus 1, then the polynomial is if alpha is 3, then factor is x minus 3. Beta is 1 by 2, then factor is x minus 1 by 2. And gamma is minus 1, then x minus minus 1. Then you get here x minus 3. Next, you take LCM, that is 2x minus 1. And here is x plus 1. This is the denominator, go that side, that's 0. Here is x minus 3, x plus 1 and 2x minus 1. First multiply between them, then you get this, and last multiply with. Then you get your solution after multiplying the solution. It is the cubic polynomial when alpha, beta and gamma are given.